So now to compare the cost of generating electricity across different types of fuel sources and different type of technology, the industry standard is converting all of the cost to what is called a levelized cost of electricity. Now, the levelized cost of electricity, the idea is very simple, and the calculation is not hard either. The idea is simply that you take all of the cost to produce electricity over the entire lifetime, right, to generate electricity. So investment cost, operation and maintenance, and fuel. So I, M, and F, that goes on top. And here is our friend, the discount factor, right? Because we're looking at it over the entire lifetime. Okay, and we will discount every year. We'll discount all these costs over the years to the present, and then we're dividing by how much electricity did this power plant actually produce. Okay, and that's much simpler. So we'll look at either this. So we'll say, okay, what is the projected, or what is the actual production every year? And again, we'll also discount that with a discount factor, and then we will divide. Now these the electricity generated is typically in kilowatt hours. So if you have on the bottom, if you have the total kilowatt hours produced over the entire lifetime, and on the top you have the dollar amount that it required to produce to produce those kilowatt hours. If you make the divide, then you will get dollar per kilowatt hour. Okay. All right. Now, if you do this for every energy source, now we can compare, right, apple to apple. We can compare solar to coal, to nuclear, to wind. Now, at first glance, right, you want to think about, do renewables have an advantage, right? And at first glance, I would say probably yes, right? There's no particular reason to think that it costs more to invest in renewable or wind. I mean, coal power plants and nuclear power plants are very expensive, and they're also very high maintenance, like. Right, so solar panels and wind turbines are not necessarily. There's no reason to think that they're more high maintenance and operation cost than let's say coal powers and natural gas and fuel, right? Wind and solar does not require any fuel at all, right? Whereas you need to buy coal and you need to buy natural gas, right? So at first glance, it seems like then the cost for renewable, right, might be very low, right? The wind and solar might have an advantage here. Okay, so what is the actual cost? So here is a website. The link is here. Let's take a look. These are collection of this is a sample from the Department of Energy, and they look at across different types of fuel. Different types of fuel. Right? So these numbers in the parentheses are the number of it's the sample size. Okay. For those of you who remember your statistics, right? These are box and whisker plots. Okay. Now, if you don't remember, that's okay. The number that we want to focus on is the median. So that is the line in the middle here. That's the 50th percentile in our data set. So that means 50% of the observations are above and below this line. Okay, that gives you the best average. So let's take a look here for solar panel. Right. So let's take for solar, right? The median price, the median cost of solar generation is 27 cents per kilowatt hour. Okay. So we see here 0.27. Okay. Now let's compare that to say coal. So pulverized coal and scrub. So that's 7 cents. All right, so that is extremely small, right? 20 cents lower. Okay, combined natural gas, right? Natural gas combustions is 15 cents, a little bit more than coal, but still lower than solar. Combined cycle gas. Now we're looking at 5 cents. Right, much lower. These are outliers, so you see these are maximum here. Right, that tells a story. What is that story? Well, until we actually look at the data set in detail, we won't know. But again, the median is what we really want to focus on, and the median is going to tell us really in a competitive market what fuel source what fuel source will be chosen or will be used, right? And so and also keep in mind that these numbers, these costs are really already include most of the subsidies for renewable energy, right? And also a lot of the taxes, a lot of the taxes, and a lot of the extra fees that coal and natural gas have to pay that renewables do not. All right, so it makes it a very so this is already with the subsidies, right? And we could do more, but we have to keep in mind how much more subsidies do we really want to like invest. Right? And as we're seeing with the case in Germany, they have invested billions of dollars, and without much to show for. Okay. All right, so the question is not, so we want to pause here for the moment and just think about the question maybe is not, should we, or should we just keep subsidizing renewable? Maybe we should think about why is it that renewable are so expensive? Why is it so costly? Because remember, right, if we go back to kind of looking at our levelized costs, right, it's at first glance, it seems like renewable energy have an advantage. So why is it so? Why is renewable energy so costly? Okay. So to think about that, we have to think about the capacity factor. So capacity factor is an industry index used, and it's very simple. It's just you take actual power output divided by maximum power, maximum possible output. All right. So here's an example. Let's do an example here. Okay. So suppose the power plant has a capacity of 1,000 megawatt. Now what that means is at its maximum. So this power plant its full potential could produce 1,000 megawatts, right, at any given time. Okay. Now it only produces 500. It produced 534,000 megawatt hours in a 30-day month. What is this capacity factor? All right, so now to calculate that, so let's go capacity factor. Let's focus on the bottom, the denominator here. So here, if we start with a capacity, 1,000 megawatt. Now I need to convert that to megawatt hour because I need to calculate work. That's energy produced. So 1,000 megawatts times 30 days. Okay. Now, if I was looking at a year, then instead of 30, I will multiply by 365. Okay. But right now, I'm just looking at 30-day month. So I multiply by 30. Now, I want megawatt hour. So I multiply by how many hours in a day? That is 24. So multiply across, we get 720,000 in the denominator. So that is the maximum possible output, right? If this power plant was running at full capacity, a full potential, 24 hours a day, 30 days in a month. Okay. Now, how much power did the power plant actually produce? 534,000 megawatt hour. Okay, so we simple divide, we find the ratio 0.74, or we say 74%. One good way to think about this is that this power, you can think of it as this power plant is running at full capacity only 74% of the time, right? Or you can think of it as it's only working 74% of the time and it's producing nothing the rest of the time. That's not really true, but it really helps us kind of compare and think about how efficient a power plant is. Okay. Now that we have the idea of capacity factor, now we can think about what is the limitation of renewable energy. All right. So some of you might know this. The world's largest solar farm is in California. It is the Topaz Solar Farm in Southern California. It is the largest solar farm in the world. To put it in context, it covers 9.5 square miles, which is 4,600 football fields. It has a capacity of 550 megawatts. Okay. Now that is how high is that anyway, right? You have no context. Most of us have no context to compare that. We'll talk about that in a moment. The problem in here we see the capacity factor is 26.6%. So it's essentially is only running at full capacity 26.6% of the time. Right? And you can see just to look at so here's a picture from Google Map. Look at the scale of this, right? So we can see it. We can see it pretty clearly here, right? Now, compare that to, let's say, right, somewhere in somewhere a little bit further down south, right? Diablo Canyon Power Plant. Now, this is the last nuclear power plant in California and is scheduled to be decommissioned, or I think it is actually decommissioned already. Okay, now let's look at the land mass, the land covering needed. 1.4 square miles, 678 football field, compared to 4,600 football field. Capacity, 2256, over 2,200, right? Almost four times, right? Almost four times the capacity of the solar farm. Okay, so a fraction of the space, and the capacity is almost four times the potential. But most importantly, capacity factor 87%. Right? Nuclear power plants are so this power plant is running essentially full capacity 87% of the time. Okay. And that is where the main barrier is. When we look at the levelized cost of electricity, right, renewables might have an advantage in the cost part, but they simply don't generate enough electricity to justify the cost. Right, or not to justify, but to be competitive. Right, the electricity produced over time is simply too little. By the way, for those of you probably a lot of you probably are thinking about the dangers in nuclear. That is a different topic, but something to consider. 3 Mile Island, it is the worst nuclear disaster in U.S. history. This happened in 1979. Right. And through my island, so here's a link. Here's a archive, kind of a retro video of the news article at the time, and people were freaked out. There was you hear things like the China syndrome, where we thought that people believe that the nuclear core will continue to melt all the way through the Earth and get to the other side of the U.S., which is they thought it was China, but it's not. Anyway, now it was eventually shut down. The nuclear power plant is eventually shut down. Right? When was it shut down? 2019. Okay. Now, this is so when 3 Mile Island happened, right? You have to keep in mind this is the worst nuclear disaster in U.S. history. This nuclear power plant is heavily scrutinized. Right? This is continuously audited. Right? And so you can be sure that it has met every safety standard that we have thrown at it, and yet. Even after a disaster, the worst disaster in U.S. history, we continue to operate it and without any further issues all the way to 2019. All right, so something to think about. Here's another picture of the capacity factors compared between the different energy sources. Okay, and here's the same problem, right? We see nuclear, natural gas, and coal, and so on, and we see wind and solar all the way down. Right, they're barely breaking the 30s. So why is the capacity factor for renewables so low? Okay, so the short answer is storage. Right, you have a lot of potential with solar and wind. However, sun doesn't always shine and the wind doesn't always blow. And so when the wind does blow and the sun does shine, we need to have a way to store all those energy. And put it simply, we simply don't have the ability to capture that energy. So you have a lot of issues with integrating wind and solar into the grid. Furthermore, right, there's another issue with curtailment. Right? So we're not going to go too deep into it, but problem with wind especially is so curtailment is basically dumping power. Right? The wind turbines are spinning, it's generating power, but the grid cannot absorb that power, and therefore the wind turbine have to be shut down. Why is that? Well, because engineering wise, right, it is very difficult, right, to integrate the fluctuations in renewable energy into the grid. Right? So that's so there's a engineering problem, a lot of engineering problem of integrating renewable energy into the grid as well, and so both of those factors causes the capacity factors to drop to be so low.